Welcome everyone. So what we're going to be talking about today is Gas Law Stoichiometry. Now stoichiometry is something that we did way back, okay? We did this a few months ago. And so let's just review real quick. Let's see if you remember what stoichiometry is. We said at the time it's this really big word and it basically is the mathematics of chemistry, but that's not what you were going to tell someone. So if someone said, hey, what's this stoichiometry thing that you're doing? What you are going to say is it's figuring out the, do you remember? Amount of one substance when?
You know the
You
amount.
know the amount of another. Awesome. Very good. Okay, awesome memory. So we're going to write that out. So it's figuring out the amount of one substance when you know the amount of another. Okay, so when we used it back in the day, what we had said was if you're using gases, we assumed that the gas was at STP. And if the gas was at STP, then we could use what number of liters per mole? 22.4. So we said 22.4 liters per mole, and that's what works if you're at STP. The problem is, are we usually at STP?
No.
Why not? Because at STP, what's your temperature?
0.
0 degrees Celsius, and that's really cold. So when we're in the lab, we're not at 0 degrees Celsius. We'd all have our coats on, right? So instead, what happens, what do we do to these problems? So what I first want to start with is, I created this little flow chart. It says, my first question is it at STP? And if you say yes, it's at STP, all you're going to do is you're going to use Stoich. We're doing this old school. You're going to use 22.4 liters per mole, and we're good to go, okay? If it's not at STP, then what we're going to do is we're going to use Pivner. Here's the only thing. Sometimes you have to do Stoich and then Pivner. Sometimes you have to do Pivner and then Stoich, okay? So here's what I always say. I say try to set up Pivner. See if you have enough information. If you do Pivner and then do Stoich, okay? If you don't have enough information, for example, if you're missing volume and moles, then you have to do Stoich first. Why can't you use Pivner if you're missing volume and moles?
Because there's two variables.
Two unknown variables. You can't do the math if you have two unknowns, okay? But if you have P, V, and T, remember in Pivner, the only other variable is R. What is R called? The gas constant. Very good, the gas constant. And R is something that actually I have it right here, so it's either 8.31, 0.0821, or 62.4. So you're going to use whichever R value that matches the pressure, okay? So you use Pivner and then you use Stoich. So let me show you how this ends up working. So the first question is at STP, and it says, how many grams of water will be produced by 58.2 liters of CH4 at STP? Here's the biggest question of the day for this, okay? How do you know this is stoichiometry? Based on your definition, how do you know that you need to use stoichiometry for this? You know one, and you're trying to find the other. Awesome. Now, what's a giveaway that it's stoichiometry? And there's a balanced equation. Nice. The balanced equation is usually a giveaway. You have not seen any balanced equations in any of the problems that you've solved so far. Now all of a sudden they're giving you a balanced equation, okay? So there are two things with, you know that you're going to need Stoich because this says water and then it says CH4. So anytime that you're switching your substance, you know you're using Stoich. Okay, here we go. Circle what you want, write what you got, throw in a bridge, and cross your units opposite. Okay, so we're looking for grams of H2O. We're going to circle what we want, write what we've got. 58.2 liters of CH4. Throw in a bridge, and I'm going to cross my units opposite. I've got liters. Well, if you remember from the switch it thing, moles were in the middle of your switch it thing, and then up here we had grams, down here we had fame. Do you remember what was down here on the right?
Amateurs?
No, liters.
Liters. Very good, it was liters. And do you remember how many liters? What did we say? 22.4, just like we said, liters in 1 mole. Okay? So I'm in liters, so guess where I can go? To moles. Perfect. So I'm going to go liters to moles, which means I'm going to use 22.4 liters for every mole. Now it's really important though that you write, we have not switched our substance. It's still CH4. Do you remember where you can switch your substance? We called it a mole ratio. Awesome. So now that I'm in moles, I'm going to cross moles opposite. So I'm going to write moles of CH4 down here. And now I can do my mole ratio. So this is what we called the mole ratio. You have to be in moles to do this, okay? So what am I trying to get to?
H2O.
H2O. So let's put moles of water on top. And now how am I supposed to get my ratio? The balanced equation, because what represents moles in the balanced equation?
Coefficients.
Coefficients. Nice, the number in front are the coefficients. So I'm looking for H2O over CH4. So what number goes with the H2O? 2. And what goes with CH4? 1. So it's a 2 over 1. We're almost done. They want our answer in grams. So I have one more step. I'm going to go moles of water. How do I go back up to grams?
L chart.
L chart. Nice. You probably have it memorized now, so you don't need an L chart. What's the molar mass of water? 18. Remember, it's 18.0. We always go to the tens place. And so then, what are you going to do in your calculator? On top, you always multiply, and then you're going to divide by 22.4. Remember, 1 always goes with the mole in this case here. This one doesn't because that's your mole ratio. So someone can calculate this, and then you can tell me what you get. 93.5. Okay, so sig figs. We've got 3, 3. This is infinite. This is a count, so you don't count that. And 3. So 93.5 sounds like a great answer. And that's grams of H2O. Okay, let's try the next one. So because we were at STP, we were able to do it old school. Okay? So now it says, same exact question. Look at this. How many grams of water will be produced by 58.2 liters of CH4? But now we're not at STP. We're at 17 degrees Celsius and we're at 1.9 atmospheres. So now things are different. Okay? So what we're going to do is, step number 1 is let's try to use Pivner. Okay? Let's see what happens when we go to fill in Pivner. So PV equals nRT. So I know that this is my volume. I know that this is my temperature, but what do I have to do to it?
Add 273.
Add 273, very good. So that gives me 290 Kelvin. And this is my pressure. Okay, so I know I have a V, a T, and a P, and I can figure out my R. So what's the only thing I'm missing? N. Awesome, very good. Okay, so this is going to be the only thing that I don't have are my moles. So let's try this out. My pressure is, they tell me, is 1.90 atm. My volume is 58.2 liters. I don't know N. Okay, you have 3 choices for R. You can either use 8.31, 0.0821, or 62.4. Which one is appropriate here?
0.821.
0.0821, why?
Because that's an atmosphere.
Good. This is an ATM. You want it to match. That's the only one. Everything else needs to match also, but it already does. Okay? So this is the 0.0821 liters times ATM per Kelvin mole. And then our temperature we know is 290 Kelvin. Okay, remember, you don't want to write anything else down. The more you write, the more likely it is that you're going to make a mistake. How do I solve for N? Where do I start? Opposite side. What do I do to these two? Multiply. So then what am I supposed to do to these two? Divide. Awesome. So go ahead and plug that into your calculator and tell me what you get, please. 4.6, like 4. Let's see our sig figs. 3, 3, 3, and this one here actually should be a decimal point 290 because we're stopping at the ones place, so we should be stopping at the ones place. So we've got 3 sig figs, so 4.64 it looks like. Yes? And then our units. Well, atmosphere cancels out with atmosphere, and Kelvin with Kelvin, and liter with liter, so what are we left with? Moles. Okay, now, that's not what we wanted though. The second part to this problem is, once we know the moles, what are we looking for? Grams of water. Okay, so now what we're going to do is we're going to take our 4.64 moles, and this is of CH4, and we are going to convert it. So we're going to go moles of CH4 on the bottom, and once you're in moles, what can you do? You can do your mole ratio. Awesome. So I'm going to go to moles of water, which we already did that. We said it was 2 over 1, so it's a 2-to-1 ratio. And then now I have one more step because I don't want moles, I want grams. And just like we did before, how do you go from moles to grams? L chart, and we said it's 18 grams for every mole. And so we're going to go 4.64 times 2 times 18, and I'm getting 167. Does that sound right? So 167 grams of H2O. Okay, and you can see that they're different. So if you're at STP versus not being at STP, They are different from one another. Okay. Last one. Let's see what happens on this one. Now it says if 85 grams of NaN3 decomposes, are we at STP? No. Okay. So what we're going to do is let's label this. So it's giving me grams, and then it's giving me a temperature, but I have to add 273, right? So that's going to make it 348. Did I do that right?
Yeah.
348 Kelvin, and this is my pressure. And then we want to know the volume of N2. Okay, so we've got our temperature, our pressure, and our volume. The only thing is here that our NaN3 is different from N2, which means we're going to need to use stoichiometry. Okay, so what I'm going to first do is I'm going to check Vintner. So I'm going to go PV equals nRT. Well, I know my P, I don't know V, I don't know N, I know R, and I know T. What's wrong? I have two unknowns. If you have two unknowns, what we're going to do is we're going to do the Stoich first, and then we're going to come back and use Vintner, okay? Because we can't fill everything in right now. So I'm starting with 85 grams of the NaN3. And I'm going to throw in a bridge. Where do you go from grams?
To moles.
To moles. Awesome. So I'm going to go grams to moles. How do you go grams to moles? L chart. So this is NaN3. It's really important that you write NaN3 whenever you're doing Stoich because we haven't changed it yet. Okay. Sodium is 23.0 and each nitrogen is 14.0. So I'm going to get a total of 65.0 grams for every mole. Now I'm in moles of NaN3. Oh, so now I'm in moles of NaN3. Here's the thing. That's nice because that's what I want. I want moles. But what moles do I want? N2. Okay, these have to be for the same substance. So if my pressure's of N2, my volume's of N2, then my moles have to be of N2. Okay, it has to be for the nitrogen. So what do I do here now? Once I'm in moles, I can do the mole ratio. Nice. So now I'm going to go to moles of N2. And here's my balanced equation. What numbers am I using? What do I have for the N2? 3. And what do I have for the NaN3? A 2. Okay, so now I do have my moles of N2. So let's do 85 times 3 divided by 65 and divided by 2. Remember, you have to divide again. Okay? It's not divide, multiply. It's still divide. Okay, so we've got 1.96, and that's moles of N2. And so now we can come back and fill in our Vintner because we have everything but volume. So our P is this 2.30 atmospheres. And our V is what we're looking for. The moles we just found, 1.96 moles of the N2. Okay, now which R are we using? We're in atmospheres. So which one would you use?
0.082.
0.0821 again. Okay, so this is again the 0.0821 liters times ATM per Kelvin mole. And the last thing is our T, and our temperature we changed already to 348 Kelvin. What are you doing here? You're starting opposite again, right? So you start on this side and multiply and then divide, and what do we get? 24.3. Awesome. 24.3, and then again, our atmospheres cancel out there. Our Kelvin cancels out there. Our moles cancel out there, so what are we left with? Liters. So if they wanted milliliters, you would have to do a bridge and multiply by 1,000 if you wanted milliliters, okay? All right, and that's basically it for doing gas law